Hi, we have discussed the linear programming generalized method in previous video. Now we are going to apply simplex method for solving the linear programming problem, which is maximizing the profit. Here, first of all, we have to make sure that all the BIs, that means, so here we are having the equation constraints here. So a1 x1 a11 x1 plus a12 x2 plus etc a1n xn less than or equal to is one inequality function, equal is equality constraint, and greater than or equal to is another inequality function. So here the b1 variable, so the b1 should be always positive. Okay, if it is negative, we have to multiply that entire equation with -1 to make the b is a positive. For example, if you are having 2x1 plus x2 less than or equal to -1, then we have to multiply this entire equation with -1, then it will become minus 2x1 minus x2 less than or equal to 1. So like this we have to transform this negative value into positive value. Then we have to add slack variables, yeah, whenever we are having less than or equal to inequality constraint to represent the unused resources. That means here you see we are having the combination of the materials x1 plus 2x2 less than or equal to 40, right? So here we need this many quantities, but here we are having only a less number of values for input raw materials. So we have to add, right, some more values, that is added the slack variable. So here I am going to add some more quantities to make that into equality constraints. So x1 plus 2x2, the here slack variable for the first equation to be s1. S means slack variable, and here the first equation is having one constraint, one slack variable, that's why s1. Then we are transforming that inequality constraint into equality constraint. After that, one more example here, less than or equal to, so second equation. So since it is a second equation, I am going to add s2. Already s1 is used in the first equation, so next I am going to use the next sequence s2. Then we are making that inequality constraint into equality constraint. Suppose when you are having greater than or equal to constraint like this, then you have to add surplus variables. That means here you see I'm having this combination, more combination. Okay, so I have more than the needed combination. So what I have to do, so here I have to subtract the combination. So for that I'm going to subtract the slack variables. Okay, so based upon this, here I am transforming that greater than or equal inequality constraint into equality constraint by subtracting the slack variable values. Okay, so that means it is exceeding the resource requirement. So that's why here we are going to subtracting that exceeded record or exceeded materials. Okay, here after that, that slack variable or surplus variables which we have used in these constraints to be added into the objective function jet. Okay, so here the objective function is taken as a 40x1 plus 50x2 here. So based upon this first example, I have used two variables s1 and s2. So s1 and s2 is added into the objective function, and importantly we have to notice that coefficient should be 0. That means this objective function should not vary when you are adding this slack variables or surplus variables into this objective function. So we have to add with 0 coefficient. After that we have to construct the simplex table by using this constraints and objective values. After that we have to find the first feasible solution. First feasible solution will be identified by using assumption. Okay, assuming some values to this variables. Okay, so which variables? X1 and x2. So here these are the objective variable, I mean decision variables given in the objective function. So we have to find the first initial feasible solution. From that, right, we have to check the optimal condition. The optimal condition is for maximization problem, zj minus cj greater than or equal to 0, right? So zj is maximization function values, cj is coefficient which are used in the objective function, right? So for minimization problem, zj minus cj should be less than or equal to 0. So based upon that, we are going to solve the problem here. Maximization function z equal to 5x1 plus 3x2, subject to three constraints. Okay, x1 plus x2 less than or equal to 2, 5x1 plus 2x2 less than or equal to 10, 3x1 plus 8x2 the less than or equal to 12. First option is we have to check these three b values are positive or negative. These all are positive values. So first step is checked, and the next step is we have to transform this all constraints into standard form, that is equality constraints. So these are all inequality constraints, less than or equal to symbol. So number of constraints are here 3, right? So based upon that, here transforming that inequality constraints into equality constraints by adding surplus variable or slack variables. Here we are having three constraints, so we need three slack variables. Okay, so for objective function, we are adding the three slack variables with zero coefficient, right? Then we are transforming that objective function, we are transforming that constraints, okay, inequality constraints into equality constraints. For first constraints I am adding s1, second constraints I am adding s2, and then third constraint I am adding s3, and all constraints made as a equality constraints based upon the transformation function, right? This step is here, just we are making this objective function into z minus, that is we brought into the left hand side, right? So now third next step is constructing the table for simplex method. Initially we are assuming some values to find out some feasible solution. So for that, x1 and x2 are initialized with 0. When you are assuming like this, then substitute the values for x1, x2 here, these three constraints. When you are substituting here, s1 will become 2, so that's what this one. And here when you're substituting zeros here, s2 becomes 10, right? Then here substituting zeros, s3 becomes 12. Then we are constructing the simplex table. Simplex table to be constructed by using these constraints and the maximization function. So here we are going to have the table header for the simplex table. This is coefficient of the basic variables and the coefficients of the maximization function, right? Maximization function is given here. So here the 5 is the I mean variables. Here we have to note down x1, x2, s1, s2, s3, all these variables from the maximization function, and its coefficient 5, and x2 is having 3, and s1 is having 0, and s2 is having 0, and s3 is having 0, right? Then next column is initial solution, and the next column is ratio. We have to divide this initial solution values divided by the basic variable values which are we are going to calculate, right? So then here these values are surplus variables or slack variables which we added in the objective function. Then this zj is calculated by using the formula here, zj equal to summation of I equal to 1 to number of variables in the rows. Okay, here three number of variables available, then the values of this respective cbi into, here we will have some values in these columns, so that is represented by using xi as per this problem statement. Then now zj is calculated, then cj is available here, so based upon that we can calculate the net value of zj minus cj. So now we will see that first we are filling the values in the table, right? already we have seen this row and this row. Now s1, for the s1 the constraint number 1. Okay, so x1 is having coefficient 1, x2 is having coefficient 2, s1 is having coefficient 1. Then here s2 and s3 are not available. If it is not available, that is equivalent to 0 s2 plus 0 s3. So here coefficient of the s2 is 0, coefficient of the s3 is 0. Then initial solution for this constraint is here 2. Then here we are going to add s2, right, second constraint. So second constraint is here we are going to take the 5. Okay, 5 is the x1 coefficient, 2 is the x2, and here s2 only available. That means s1 is 0 and s2 is s3 is 0. So s1 is 0 coefficient, s3 is coefficient 0, and s1 s2 is 1. The initial solution is here 10, so it is denoted here. Then third row here, so third row with respect to s3 of the constraint number 3. So 3 is the coefficient of x1, 8 x2. Then here s1 is s1 and s2 are not there. That means 0 s1 plus 0 s 2, the right. So 0 s1, 0 s2, right. Here 1 s3. Initial solution is here 12, right. So now we have done this one. Now here we have to calculate zj, right. Zj to be calculated based upon this formula. So this is z1, this is z2, z3, z4, z5. J means column. Okay, so now first one we have to calculate here. You see z1 equal to, the based upon this formula, cb1 x1 plus cb2 x2 plus cb3 x3. So here I is representing the number of rows. Okay, right. So here the first one here, the value we are taking the s1. So these values are taken from the coefficient of the s1, s2, s3 from the maximization function. So you look at here the maximization function here, which is having coefficient 0, 0, 0 for the s1, s2, s3, right. Those, these are the values of s1 and s2 and s3, right. Now we are going to calculate the value cb1. Cb1 is here 0 plus, okay, then x1 is here this value. Okay, right. First column, right. Then cb2 and x2, the row number here. So row number 5 here 0. So 0 into 5, right. Then next one is I is 3. So the row number 3, 0 into cb3 into this value 3. Okay, so when you are applying the arithmetic calculation, you will get 0. Like that, when you are taking the z 4, okay, z4 when you are taking, right, here cb1 is 0 into 0. Okay, 0 into 0. Then cb2 0. Here this one is also here 1 actually. Okay, this is 1, right. Then here it is 0, here it is 0. So that is this one. So it is becoming as a 0. So like this we have to calculate the values. Substitute these values into the table now. So all are zeros. So now we have written the z1, z2, z3, z4, z5 here, right. Next one here we are going to calculate net value zj minus cj, right. So zj is here 0 minus 5. So here we will get minus 5. z2 0 minus, right, this one 3. So minus 3. Then 0 minus 0, right, 0, right. Then 0 minus 0. So here 0. Then 0 minus 0. So we will get 0. So now we got the values like this. Then here we have to check the optimal condition. Zj minus cj should be greater than or equal to 0, but here it is not true. Okay, it is false. If it is false, we have to go for next iteration. Okay, so in the next iteration, what we have to do before going to that, we have to identify key column, or it is called pivot column. Okay, key column or pivot column, that will be selected based upon the least value in the zj minus cj. Okay, so least value in the sense here we are having 5 values. Among these 5 values, minus 5 is the least value. Then that will be your key column, right? Then we have to identify pivot row, right? Pivot row or key row, right? So here the key row is called leaving variable. That leaving variable that should be selected right now. So here that will be selected based upon the values of here calculated ratio. The ratio is calculated based upon the this initial solution and the key column values. Okay, so here the 2 divided by its corresponding value 1, 10 divided by its corresponding value 5, 12 divided by its corresponding value 3. So now we got the ratio is 2 to 4. If it is fractional value, suppose 3.1 means you have to take fractional value also, right? Here in this example we are having two twos minimum values. If it is similar, then we can select randomly any row. Here I am selecting s1 is a pivot row. Okay, s1 is the pivot row, right? Next when you are selecting the key column, and here this is the key row, when you are selecting this, the intersection value is selected as a pivot value. This one is selected as a pivot value, right? Now one is the pivot value. Based upon that, we are going to update the row 1, right? S1, right? So for that, what we have to do, the existing value divided by the pivot value, existing value divided by pivot value, right? So like that we have to divide, and also we have to update. So here the s1 will be replaced by this column value. This is called entering variable. Okay, entering variable. The s1 is called leaving variable. So s1 is leaving from the row, and x1 is entering into this row. So as per that, x1 is entering into this row. Here this is the coefficient of x1. Earlier we had the coefficient of s1, this one, right? This one is having s2's coefficient. Like that, now we are updating this row. This is the existing value of the s1 divided by pivot value. So pivot value is here key value, or pivot value here is 1. Then this is existing value divided by 1, existing value divided by 1, existing value divided by 1. So now we are updated the values. After updating, right, now we have to make this remaining row also to be updated. So what is the aim? So aim of this updation to be this remain the value available in the key column to be 0. Okay, so the values available in the key columns to be 0. So for this we are going to apply the formula, right? The new value, right, new value to be 0. For that I am going to use existing value 5. Okay, existing value 5 minus, right, the corresponding key column value. This is the key column for this example. So corresponding key column value is 5. So 5 into corresponding key row. This is the key row, right? This is the key row. Corresponding key row value is here this 1, right? Then divided by key value, right? Key element, that is the pivot element. Okay, pivot element here 1. So divided by 1. You see, when you are substituting the values, 5 minus 5, it will become 0. So our aim is fulfilled. So next one you have to use this one. So here existing value is 2 minus corresponding key value, right? So corresponding key column is here this one 5. So 5 into corresponding for this row, for this value, corresponding key row value is 1, right? 1 divided by pivot value 1. So you will get minus 3. So like that we have to calculate for entire row. So when you are calculating for the entire row, you will get the values like this. Okay, you see, minus 5, right, for this place, and for this key column value is 5, right? You see, key column value is 5, and corresponding row value is 0, and divided by pivot value is 1. So when you are applying, you will get 1. Like that Here for this value 0, right, 0 is existing value, and corresponding key column value is 5, and corresponding key row value is 0, then pivot value is here 1, right. So you are applying the formula, arithmetic calculation, it is becomes 0. Then here 10 existing value minus corresponding key column value is 5, and corresponding key row value is 2, then divided by here pivot value 1, you are getting the value 0. So now these values to be updated in the S2 row. So those values updated as per we calculated in the previous slide. Then still we have to update the S3 row. Here also our aim is to make this value as a 0. So same formula we are going to apply. The existing value 3 corresponding key column, this is the key column for this example. So corresponding key column value into corresponding key row value 1, right. 1 divided by pivot value is here 1, so 1 is used here for dividing, then you will get 0, like that. This one 8, so here 8 also existing value minus corresponding key column value is 3, then corresponding key row is this one 1 divided by 1, you are getting 5, like that. For 0 corresponding 0 minus, okay, corresponding key column value 3, right, then corresponding key row value 1 divided by key value is 1, 0 minus 3, you are getting minus 3, like that. Here you are going to calculate for this 0, corresponding key column value is 3, this 0 is existing value, 0 minus corresponding key column value into corresponding key row value is 0 divided by pivot value is 1, so you are getting this value, like that. For this one 1 minus corresponding key column value is 3 into corresponding key row value is 0 divided by pivot value 1, 1 minus 0 1, like that. 12 minus corresponding key column value 3 into corresponding key row value is 2, then divided by pivot value 1, 6. So now you have to update these values in the slides, it is also updated. So now ZJ to be calculated. Initially ZJ is having 3 zeros, so now we have to calculate ZJ, already we know, right. How do we calculate the ZJ? Here 5 into 1 plus 0 into 0 plus 0 into 0, that is the Z1, right. So here based upon that you will get the 5, like that. Z2 here 5 into 1, then 0 into minus 3, then 0 into 5, so based upon that you will get 5, right. Then Z next one, this column, right, 5 into 1, 0 into minus 5, 0 into minus 3, so based upon that you will get here 5. The like that next one is S2 row, S2 column. So in the S2 column 5 into 0, right here, right, 0 into 1 and 0 into 1, okay, you will get here 0. Then you have to calculate next one is this one, right, right. So here in the previous one 0 into 0, okay, this one, right. So now we are going to calculate 5 into 0 and 0 into 0 plus 0 into 1, this one, okay, you are getting 0, like that. Now we are going to update all these values into this one, so triple five and two zeros, right. Now we have to check the ZJ minus CJ. So ZJ minus CJ, 5 minus 5 it is 0, 5 minus 3 it is 2, 5 minus 0 it is 5, so 0 minus 0, 0 minus 0 is 0. Now we have to check the optimal condition, ZJ minus CJ, right, greater than or equal to 0. So 0 greater than or equal to 0, yes, it is true. 2 greater than or equal to 0, true. 5 greater than or equal to 0, true. 0 greater than or equal to 0, true. 0 greater than or equal to 0, true. So now we can stop the algorithm. So now, as of now, we have to check what is the solution for x1. X1 is here 2, x2 is not available, so it will become 0. S1 is here not available, it will become 0. S2 is 0. S3 is here 6. So these are the values now. So x1 is 2, x2 is 0, s1 is 0, s2 is 0, s3 is 6. So now you substitute the values into the maximization function, right? A maximization function is here 5x1 plus 3x2 plus 0 s1 plus 0 s2 plus 0 s3. When you are substituting all these values here, okay, you will get 10 is the value. And also you can check with the constraints. You see x1 is here 2, x2 is 0, s1 is here 0, so it is equal. 5x1, 5 into 2, okay, 10 plus x2 is 0 plus s2 is here 0, so 10 equal to 10, it is also satisfied. Constraints are satisfied. Okay, 3x1, 3 into 2 is 6 plus 8x2 is 0 plus s3 is here 6, so here 12 equal to 12. So this maximization function is satisfying the constraints, right, based upon this values we found in this example. Like this we can check the constraints. Thanks for watching.